Hi, welcome to this Learning Nginx course. This is the first lesson, called Introduction, where we'll be going over the things that will be covered on this course and some of the things you'll need. So we're going to cover setting up Nginx using a technology called Docker. This is an alternative to how you would think you would install it on a typical Windows or Linux machine, but we'll go into more detail on this in that episode. We'll also set up what's called a reverse proxy. This is a very typical task or use case for Nginx. We'll also then add HTTPS or SSL to our reverse proxy. We're also going to go over how you can use Nginx with PHP, a popular programming language. And we're also going to go over utilizing Nginx as a video streaming server, which is one of the use cases Nginx can be used for but isn't particularly popular. Finally, we're going to cover load balancing using Nginx using a method called the round robin method. In terms of what you'll need, in this course we're going to use a Linux virtual machine, or if you don't have access to a Linux virtual machine or VPS, you can use WSL. The reason for this is generally in industry you'll find that Nginx is deployed on Linux and very rarely deployed on Windows. Therefore it's probably best that you learn how to do it in Linux. If you don't know how to use Linux, I'll go over all the commands so you don't need to worry about that. You're also going to need a basic understanding of computer networks, otherwise this course might be hard for you to follow. Later on for the video streaming section, you're going to need a copy of OBS or Open Broadcaster. This could be easily downloaded. I'll show you how to do that too. And finally, you're going to need a text editor. For example, you could use Visual Studio Code, or today I'm going to use Nano within the Linux virtual machine. So that's everything we'll be covering in this course and everything you'll need. So hopefully you'll be ready for the next lesson. Hi, welcome to lesson 2. We're going to go over how you set up Docker and how you set up a module for it called Docker Compose. So you might ask, what's Docker? Why are we going to use Docker when we could just install the software directly on Windows using an install binary, or on Linux using a package manager like apt-get or yum if you're using a Red Hat or CentOS distribution? Well, Docker, the containerization platform, basically will allow us to neatly package our app and deploy it. Docker, as a general sort of preface, greatly simplifies the deployment regardless of the environment. That means if you had a machine running many Docker instances and you wanted to move it to another machine, say running a different operating system, let's say you go from an Ubuntu server to a Red Hat machine, you could just take all the Docker Compose files and all of the data folders for those Docker applications, move them across to the other machine, simply install Docker, and then run the Compose file and everything will work. You don't have to worry about setting up the app for the specific idiosyncrasies of that operating system. It's also very usage efficient in terms of resources because it shares the overall operating system kernel. So this will allow us to run multiple instances of the same application on the same machine. Obviously you have to run that on different network adapters or ports, but we'll go over that later on, especially when we go over the load balancing section. Okay, so the first thing we're going to actually need to do is we're going to want to come across to our Linux virtual machine or VPS or Windows subsystem for Linux if you don't have either of those. That just allows you to install a installation of Linux on top of Windows, which is very useful for learning. It's not covered in this series, however there's plenty of documentation online for how to get that set up. In this series we're going to use an Ubuntu machine. The same commands will apply for a Debian-based machine. However, if you're using a different distribution, unfortunately some of these commands will not work and you'll need to follow the ones for your distribution. So the first thing you're going to want to do is run apt-get update. What this will do is it will update basically the package manager. You can think of the package manager like a store where you can go and get applications. Well, basically this is checking what's in stock. It's the best way I can put it. So once you've done that, now you have a list of what's in stock. You can check if anything you have is out of date. So you could do apt-get space upgrade, and then this will go ahead and upgrade. Now in my case I have nothing to upgrade, but if you did it would tell you to push Y, so you should go ahead and do that. It's good practice before you start to make sure everything's up to date. In order to install Docker, we're going to use a simple install script, and that's going to require something called curl. Curl allows you to download download files on Linux. So I'm going to run apt-get install curl. In my case, curl is already installed, and we can check that by just typing curl. And you'll see it says curl, try curl, or curl -- help, and you can see that curl's working properly. So we're going to want to go to this GitHub repo, which there will be a link for, and this is basically an automated script for installing Docker to make everything a lot easier. Now, you should make sure you verify that it is this correct GitHub repo, because there is the chance there could be malicious repos that try to look like this one, where the script is not very good. So we're going to go ahead and we're going to copy this curl command, come over to our Linux machine, and we're going to paste it. Now, if we type ls, which will list the files, you will see get.docker.sh, and if we quickly use nano, the text editor, if you don't have that installed, you can do apt-get install nano. However, this comes with most distributions. We can now do nano get, and you can use tab for autocomplete, docker.sh, and you'll see that this is actually what's called a shell script or a bash script. Now, we don't need to go through all of this, but this is basically what we're going to execute. So now to execute this, we're going to go ahead and type chmod, which basically changes the permissions on a file, plus x for make it executable, and then get docker.sh. Now, if I type ls again, you will see get docker.sh is green, which means it's executable. If you're wondering, by the way, I type clear just to clear the screen. So now we're going to do /get docker.sh, and this is going to go ahead and automatically install Docker for us. Okay, so when you're done, you should see something like this, and it'll give you a warning about root. I'm logged in as root. You generally shouldn't do this, it's not advised, but if it's a local machine, it's not a problem. However, security practices in general are out of the scope of this training. If you want to learn more, I suggest you Google about root and sudo and groups in Linux. So we're going to go ahead and type clear, and just to check this works, we're going to type docker space info. Now, if you've got nothing here and you've got some sort of cannot connect to Unix socket or something like that, that's probably because you need to use sudo. In my case, as I'm already logged in as root, this won't have an effect, but you would do sudo docker info, and you'd need to type sudo in front of any of your commands for Docker. So we could see this is all running, and we could do one more test, which is docker ps-a. You can see no containers are running. Okay, so in this next section, we're going to install Docker Compose. In our case, we can actually do apt-get install docker-compose. And then this will go ahead and use the package manager to install Docker Compose. Now if I do docker-compose, you'll see all of this stuff comes up. So Docker Compose is working. Now if when you do that it doesn't work, you will have to follow the manual instructions over on the Docker docs, which are down here for downloading the CLI plugin and enabling it. However, 90% of cases this will work, so that's what we've gone ahead and done. So now we are set up with Docker Compose and Docker. Okay, so now we have Docker Compose. Let's just sort of check our whole setup works. So we're going to go ahead and we're going to go nano, and any file with Docker Compose you'll want to call docker-compose.yml. Now we're going to create a folder for each application. So in this case, we're actually going to use Apache, which is a different web server, but just to show that our Docker and Compose is working, so we're going to make a directory called Apache_1. We're going to cd into Apache 1, and we're going to create a docker-compose.yml file. And I'm going to paste one in that I've already created here, but you can see you have the version. This is the version of Docker Compose. You have services. You can have multiple, but in this case we've got one. It's named Apache. The Docker image we're using, these can be pre-made. In this case, this is a pre-made one for Apache 2. The container name. In this case, I'm just going to change this to example_app_demo. And then you have this port mapping. So this is basically, this is internal to the container. So the container will broadcast on 80. And then externally to the rest of the world, it will be on port 8080. And then here you can see that this is /website. So the current directory /website will map to internally to the container of user local Apache htdocs. Now this is where Apache stores its web pages. So what you're going to want to go ahead and do is you can change this if you want. So in my case, I'm just going to call this data. And this will automatically create data. So if we do Control X in nano and Y and save, and if I clear this and do ls, you'll see docker-compose. If I type docker-compose and I type up you'll see it will pull the image. And now it will go ahead and run the server. Now I'm going to do Control-C to exit this a sec, and I'm going to use cat to just quickly look at that Docker Compose, and you can see that our external port here is actually 8080. So if I go ahead and run this again, so now as you can see we're on 8080, and you can see here in the background that when I refresh, my server's working, or my Docker application. So if I do Control-C here, it's going to stop the app, and what I'm going to do is I'm just going to put a file in the data folder, so cd data, and I'm going to go ahead, I'm going to use nano, and I'm going to create a index.html, and I'm just very quickly going to create some very bad HTML. This is not in the scope of this video. This is an out-of-date tag, as anyone who does HTML will know, but we'll do for now. Okay, so now we have this file, as you can see. What we're going to do, I'm just cding back a sec, so cd ... goes back. And we're going to do docker-compose. Now before we did up. Now this brings it up, but if I were to close this SSH session, the application would not work. So what we can do is -d, and this will detach it. So now it's running in the background. Now you might say, well, how do I then stop it? Well, you do docker-compose. You have to be in the same file as your docker-compose file. You can do docker-compose stop. This will stop the app. Or you can do, if we do docker-compose up-d again, and let's say we want to see what's happening on the screen, you can do docker-compose logs -f for follow. And now, if we refresh this, you'll see hello user. So that's the end of lesson 2. You have Docker set up, you have Docker Compose set up, you know how Docker Compose works, and we've created a very basic Apache web server. Now obviously Apache is not the web server we're going to be using in this series, but I just used it to create a basic demonstration of how we can go ahead and use Docker. Welcome to lesson 3. In this lesson we're going to be going over setting up a reverse proxy. So we're going to first explain what a reverse proxy is. So here we can see multiple users accessing example.com. They go through the internet and they hit the reverse proxy. Now first, without a reverse proxy, you go through the internet and you'd hit one server, and this server will respond to you. But let's say you have multiple machines on your local area network or within your business, for example these ones here, and these machines you want to not directly connect to the internet. You want to send them through one public machine. So this machine is publicly facing the internet. You go through, and then it routes your request to something on the internal network, meaning you don't have to expose these out to the world, which is very good for security. Also, later we're going to add HTTPS to this proxy, which then means everything to the internet will have HTTPS, and we don't have to get internal certificates for everything on the internal network. Now, yes, technically, that does expose you to security risks. However, you shouldn't worry too much about HTTP being used in your local network. Your local network should be secure. So, let's go ahead and get this set up. Okay, so last time we set up this Apache 1 instance of Apache as just a basic web server. Now we're going to want to make some changes to this. So what we're going to do is we're going to look at the Docker Compose, and you're going to want to remove the ports that were here, and we're going to give it a host name. This is so it's identifiable when we put it in the Nginx or Nginx config later. We're also going to add this networks default external docker_net, and this is so this container can communicate with our Nginx container, so we can forward through requests. We've removed the ports here, so this container is no longer accessible to the internet, and everything will go through our reverse proxy. All of these config files I will put in the notes below the lesson, so you can go ahead and copy them in and change them as needed. So we're going to make sure this is running, so docker-compose, let me just, I think it's up at the moment, Yeah. So you would do docker-compose up-d. And then what we're going to want to do is we're going to want to create a folder. So make directory, we'll call this one ng1. As you can see, I've already done it. And in ng1, we're going to create the Docker Compose for Nginx. So version 3, services is Nginx, and we're going to use the image Nginx or Nginx. I use them interchangeably. It's a bit of a debate how you pronounce it, but pronounce it how you wish. So in the image, we basically use the latest version of the image, and we give it a container name, ng1_reverse proxy. I'll give it a volume, so dot/data maps to etc/Nginx, and that's basically where all the config data is stored. Now here, because this is the one that's going to be accessible from the public internet, we do want to map port 80 out to port 80, but we want to join it to the internal Docker network so it can still go ahead and access the other container, right, that isn't showing on the internet. So networks default external, and make sure these network names match, so docker_net. When you first run the container, it might say, hey, this network doesn't exist, run docker network create, I think it is. Go ahead and follow that prompt if it comes up. So now we need to go into data, and we want to use this nginx.conf. So we do nano nginx.conf. And this again will be in the notes, but we need to set up the global event block. So this is the worker connections. And what the worker connections are basically the amount of connections that can happen to the process. So in this case, it's 1024. You can see with the hash here, these are comments, so we can go ahead and delete that if we don't want it. Okay, so I lost connection there, so I just had to reconnect quickly. So the first thing after this global event block and the worker connections you'll have is the HTTP server block. And you can see here we're setting up what's called an upstream. This is basically another server we can connect to. In this case, it's going to be our Apache container. And we're going to name this upstream backend, okay? Although, actually, just to make it more understandable for the tutorial, instead of backend, we'll call it Apache_Docker. And then we say that this server is, where can we get it? Well, we can get it by the host name of the container, which we set, if you remember, in the Docker Compose for the Apache machine. And it was called Apache Server 1. If it's on another port, you'll need to add the colon and say 8080, but obviously it will just be on 80 if you've followed everything. For reference, all of these configuration files will be available below, so you can copy them in and change them. So now we've set up our upstream called Apache Docker, which is pointing to Apache server, which runs in that Apache server 1, that runs in that other Docker container. Now we need to set up the actual server that will listen in. So we set up a server to listen on port 80. 80 is the default port for HTTP. And then we set a server name. And the server name is the domain name of the, it's the domain name that's linked to this web server. So you'll need to set up a DNS record that will resolve your IP address. So this could be test.com, for example, or in my case, I've set up a local DNS here called cat.ultra. If you do not have this, when you go to the just a plain IP address and it goes through this, it will basically see that the request has come from the IP address and not the matching domain, and it won't work. And the reason for this is when you use, it's called the premise of virtual hosts, but when you use the domain name, because when you send a request to a web server, you basically say, hey, I came from this DNS record or this domain name, it can then route you to the files. And that allows you to have multiple websites running on one server. Otherwise, you need multiple IP addresses. You know, each web host would have to have 300 IP addresses for its clients. Instead, they can run 300 clients on one IP address and set up multiple of these server names and just change the domain name. So all of these clients' domains all point to the same IP address. But because when they send the request over, have the different name, they'll get passed to the right place. So now we want to set up the location of /, so anything basically, to be proxy_pass, so passed over or proxied through to, now this is wrong, this is HTTP backend, but if you remember, we changed this to Apache Apache_Docker. So this upstream Apache Docker that points through to the server Apache server. So you can kind of see how this works, right? You go to cat.ultra and it passes you through to Apache_Docker. So we go from here and we get passed through to Apache_Docker, and Apache_Docker will then forward it through to Apache server 1, which this is the host name set up in the Docker Compose for the Apache server. Now these bits under it are basically setting headers. We want to proxy some of the headers through as well, because otherwise the receiving machine, in this case Apache_Docker, will see that everything has come from the proxy, when this is the case, but actually we want to basically say, hey, no, you came from the original client that made the request. You didn't come from the proxy. So that's what these are. So you can copy these out of the configuration. Then you want to do Control X and Y. And we'll want to, I'm going to go ahead and run docker ps-a, which shows all docker ps-a, which shows all the containers that are running. And you'll see that our HTTP server or our Apache server is running, and our Nginx or Nginx server is not. So now if we go ahead and cd ... to come out of data, we'll want to do docker-compose up. We won't detach it yet. And you should see, hopefully, that it just keeps running and it doesn't close. Now you'll see here that the default conf is not available. That's okay. And everything else looks all right. So what we can do now is when we go to cat.ultra here, we should see it get proxied through. So if I do a refresh here, you'll see that my browser is going through and it's being proxied across. So the way we can sort of check this is if I go ahead and Control C this, so this is stopping the reverse proxy now. Just give it a second. Okay, now if I go to the page, you'll see this spins, okay, because Nginx isn't responding. Our Apache backend is still up, but we can't access it directly because we're going through reverse proxy. So I'm going to go ahead and do docker-compose up-d to detach it, and now our page will come back. And what we can do now, if we cd ... and we go into Apache 1, we do docker-compose logs-f to follow the logs. You can ignore this server name, it doesn't matter here. You will see that the request is coming from 172.20.03, which is actually Nginx. You see, as I refresh this? So Nginx is now running. For example, if now I go into the data on this Apache server, and I do nanoindex.html, and I say, let's do a header 3, hello from Apache 2. Not sure if I have to restart the server for this, we'll find out. Nope. So now you can see that this is running. And also, just to sort of prove this one step further, if I go docker-compose down, now Nginx is still running, so that first 80 block is still gonna, that 80 server block is still gonna respond to us. But you'll notice, might take a second, but it should respond with a gateway error or something similar. Or if it doesn't, we can check the logs. So ng1 docker-compose logs-f. Yep, you can see here it's failed. It came from cat.ultra and it's failing to connect to the upstream client. So it's failing to connect to the other Docker container. And now, eventually, you can see we get a 502 bad gateway. So if you get 502 bad gateway, it means, hey, Nginx has replied, but I haven't been able to send you through to the server you wished. And we'll just quickly fix that. But if we go back to Apache 1, and we do docker-compose up-d, and everything is back. So that's how you go ahead and set up a reverse proxy. In the next episode, we're going to go over adding HTTPS for this. but the requirement for that is you must have a public domain. So cat.ultra is a local domain here, and not a public one, so you need like a .com, a .info, a .dev, a .org, any of the public domains. You'll need one of those as a prerequisite to get HTTPS working using something called Let's Encrypt, but I'll explain that more in the next episode. Hi, welcome to lesson 4. In this lesson we're going to be adding HTTPS to the reverse proxy that we set up. So let's go ahead and head over to the terminal. Okay, so this is actually being created in a slightly different order. So you're going to see the config here has changed because I'm doing this, I'm recording these lessons not in order for various reasons. However, we're going to show how we can add HTTPS to our reverse proxy. Now, HTTPS requires a certificate from a trusted central authority. So this requires them signing the certificate for you. The problem is these certificates cost money. So you can get these from people like GoDaddy, for example, and get them signed, or we can use Let's Encrypt, which is an authority that allows free certificates. Now, in order for Let's Encrypt to verify that we own our domain name, we have to do some things, but that's okay, I'll walk you through them. And we'll be able to generate our free certificate and set it up with Nginx. Now, you're going to need a domain name, a public domain name, and you're going to need your A record or your main root set to the IP of your public-facing machine. So, I've got a domain. I'm going to have to blur it out in this tutorial series. However, it is set up and pointing to the IP. The first thing you'll need to do is we're going to install a tool called certbot on the main machine itself, not within Docker, and this will help us set up certificates with Let's Encrypt with ease. So, if we do apt update first to update the repository, and then we do apt install certbot, and then Y for yes, and we're going to go ahead and push OK to that, and OK. This might not pop up for you, but that's okay. So now we are done. Now, in order for Let's Encrypt to verify we own our domain name, they need to basically grab a file that certbot will put on our web server off of it and then check that it matches. Now, this is our reverse proxy, so it doesn't actually serve files itself. Other machines serve them. So what I'm going to do is I'm going to quickly go into my into my Nginx config for this reverse proxy. You'll see there's lots of stuff in here that won't be in yours, but don't worry about that. So I'm going to leave nodes 1 enabled, and I'm going to do docker-compose up-d. Cool. So this is pointing to a server I've got set up called node 1. In your case, it'll be pointing to your Apache server, so you'll want to go into your Apache directory. However, I'm going to go ahead into node 1. And I'm going to make sure node 1 is running. You'll want to do the same with your web server. CD into data. Cool. So now, if I come over to Chrome, so here I am at my domain, and you'll see it says hello from node 1. This is the web page, and this is linked to my domain. Yours will obviously say what your Apache server says. Now what we're going to want to do is we're going to want to use certbot. So what we're going to do is we're going to say certbot, and we only want the certificate, so we're going to do cert only, and then we're going to tell it that we're going to use our current web server, and we're going to tell it where our directory for our web server is. So that would be web root-path /. That means the current directory because we're already in data. So then if we go ahead and run that, it will say you need an email address, and this is used for renewing as well as security alerts. So I'm going to put one in now. And then it will ask you to read the terms of service on their website. which I was going to show you. However, the PDF doesn't work, which is quite funny. Try one more time. Okay, well, you should read the terms of service. I've obviously read them. And then we're going to type Y for yes. And now it will say, would you be willing, once your first certificate is successful, to share your email address with the EFF? They do a bunch of really cool work, actually. So I'm going to go ahead and say yes. And now it'll say the account is registered. Please enter the domain name you would like on your certificate. So this is simply your domain name. Just going to double check what mine was because I forgot. Yep. And now it's going to request a certificate. And you'll see that it says success. Your certificate exists over in etc let's encrypt live / the domain name. You get a full chain.pem and you get a, which is a certificate, and you get a private key. So that's great. So what we need to go ahead and do now is we need to basically set these up with Docker. So what we're going to do is we're going to go into CD. We're going to do copy or CP, and we're going to do from etc / let's encrypt / live, and then your domain name. If we push tab, you'll see there's a few different PEM and certificate files. I'm going to do a * to /. And now what I'm going to do is an ls. Now, obviously, we shouldn't leave these right here. That would be rather disastrous because you would put your private key in a public location. So what we're going to do now is go back one, make a new folder called SSL, and we're going to cd out, then we're going to cd in back into data, and we're going to copy anything .pem to 2 directories back, SSL, and anything okay, they're all PEMs, so that's fine. And then we're going to do rm *pem, like so. And we're going to remove this readme because that's not very helpful. Okay, so now in our SSL folder we have all of the files we could possibly need. So we need to make sure that this Docker Compose is modified now. In fact, I've put this all in the wrong place. I could edit this out, but everyone makes mistakes, so I'm going to leave it in. Because obviously this is the node we use to capture the certificates, I should actually copy it to the Nginx machine, and so should you. So we're going to do move -r for recursive /SSL, and we're going to move it 2 directories back to ng_1 /SSL. Okay, I don't think I need -r. There we go. And now we're going to go into our Nginx reverse proxy, because this is what we want to add the SSL to, not the internal node. So now in SSL we have all the files. Perfect. So what we're going to do is we're going to go into the Docker Compose, double check all of that looks good. Now port 80 is open, but we also want to open port 443. This is the port used for SSL, so we're going to go ahead and do that. So 443:443. Oh, like that. And do a yes. We don't need to compose this up yet. Now we're also going to go into Docker Compose, one more time, and we're going to map /SSL to let's create one in /etc/ SSL etc/SSL, yeah, and do a Control X and a Y. Now we want to go into our data and into our Nginx config, and we need to add some stuff. Okay, so up here on our server, we've got listen 80 currently, and we want to change this out to listen on 443 SSL. I'm just going to copy this from my notes to make it quicker. And we're also going to want to set our SSL underscore certificate and our SSL underscore certificate key. So copy these two out again just to save some time of me typing it wrong and then having to redo it. Okay. Now, if you remember, we mapped it to etc/SSL, so we want to do etc/SSL/private key and etc/SSL/full chain, and then that should be it. So I'm going to reiterate this slightly just to make it clear. So what we did, we went over to our public-facing node on the reverse proxy, or your Apache. We went into the data folder. We used certbot to create the SSL files. We then moved the SSL files out of there into our reverse proxy. And we put them in SSL. We then mapped SSL to etc/SSL, and then we edited our config. So now if I do docker-compose, let's check it's down first, and do docker-compose up. Let's have a look what happens. Okay, it says it's ready to go. So now, if we go to our domain and change the front of it to do https:// you will find that your SSL is now working. Now, this is the latest version of Chrome. It used to be there'd be a nice green security lock. However, it's fairly obvious if it's not working because it'll throw a big error and say that the site is not secure. But if you go ahead and you click on these, I don't know what you call them, sliders, and then where it says connection is secure, you'll then see certificate is valid. And if you click on that, your certificate will open up and show you the public key. So that's how you use SSL. With Nginx, if you were not using Let's Encrypt and you bought certificates, you would just do the same thing, except you'd get those files from your provider from their web panel. This one's a little bit more complicated, however it's fairly important on the modern web to use SSL if you can. There are far more advanced things you can do, like redirecting HTTP requests to HTTPS, which is not covered in this series. However, now you have the basic understanding of how the Nginx configs works, you should be able to do your research in order to set things like this up. In this lesson, we're going to be using Nginx with something called PHP. So the first question you might have is, well, what's PHP? Well, PHP is a server-side scripting language mostly used for web development. It allows basically dynamic content on web pages, for example, to grab info from a database and display it on the page. You use it alongside HTML to create these interactive web pages, and it's widely used for building all sorts of web applications. It's actually used on over 70% of websites. However, a lot of people now will say, oh, it's out of date, you should use Node.js, or use something like React with Node.js, or use Flask. However, PHP is still very popular and very viable and works very well with Nginx. So we're going to go ahead and I'm going to show you how to set it up so you can serve a PHP file or page on our server. Okay, so here we are back on the terminal, and I'm in a folder called ng_php. Now we're going to take a look at this Docker Compose file, and it's going to be very different to the ones we've done before. So the first thing you'll notice is we're using a slightly newer Docker Compose version, 3.9, and you'll see there's multiple services here under the Service tab. For example, there's one called Web that runs Nginx latest. We've given it a host name of ng_php, and what you'll see is ./data. In that folder, we now also have an HTML folder. that points to var/www/html. If you're running Nginx on a normal Linux machine, this is where the static files are hosted. For example, if you just had a homepage called index.html, this is where it would be served from. And because we're not doing a reverse proxy, but we're actually hosting web files, we're going to need to set this up. So we're mapping data/html to var/www.html. We're also here using default.conf instead of nginx.conf. The reason we're doing this is actually just to show you that you can interchangeably use the two. The binary will normally look for nginx.conf, however it will also look for default.conf. So just to show you can use either, I'm going to use default.conf in this example. And you can see we map default.conf in data to etc/nginx/conf.d/default.conf, which is where it would be outside of Docker. You'll see there's this links section which links together another container here called PHP FPM. This is an alternative to fast CGI, which is the PHP processor we use with Nginx, which is very quick. So the PHP processor can basically take the PHP file and run it and return back to the Nginx server what it needs to send out to the client. So we link these together using this links, and then we declare PHP FPM. We're using PHP 8, so that's why it's PHP 8-FPM. And you'll see here, PHP also needs to read the PHP file. So we map the same data/HTML down here, and we point it to the same place, var/www.html, within the PHP FPM. Because what's important is these two will be separate containers. And then because we're going to join this up with our reverse proxy we made earlier, we haven't got any external ports forwarded here, and we're just connecting it to our default external network called docker_net. So if we go into data now, you'll see we have a default.conf, and this looks fairly different than you might have seen before. So we have this server block that opens, and then we have the first bit. This basically sets the order of the index files that will be served. So it will look in that folder for an index.php first. If it can find one, it will serve that one on request. If it can, it will look for an index.html. And if it can't find either, it will fail. We then have a server name, which we went over the premise of that in the previous reverse proxy episode. And then we have this error log and access log. Now, these aren't exposed in the Docker Compose at the moment, but if you were to map two files to these within the Docker Compose, you'd be able to access the error.log, which would display when there are errors in your PHP code, and the access.log, which is just a simple log showing each client as it accesses your server. Then we have the root, so this is where the files are that will be accessed. So in our case, it's var/www/html. And then under this, we have the location block that basically matches the requests ending in PHP. And then we have some fast CGI options. So in this block we have try files. So basically, if it can't find the file, it will return a 404. We split out the paths for the request, and we pass through to PHP FPM running on port 9000. So this is the other container, and we set where the index is to index.html. We include some basic parameters, and then we also include the standard fast CGI scripts needed. So you'll be able to copy this file out. It will be below. So once you've done that, we're going to need to create a PHP file to actually serve. So you'll see here I've created in the HTML folder a index.php. So if we look at this, you'll see this is opened with a PHP tag, and this is closed with a PHP tag. Now, this tutorial is not going to cover PHP, but I just want to show that it works. So in this case, we're going to calculate pi, which you wouldn't be able to do with HTML. So we've just written a simple function here called calculate pi. You can feed in the number of iterations. Then we do the actual calculation for pi. We return the output. We set the iteration, so how many iterations we want. And then we set calculate pi, the string, to equal calculate pi's what the function returns, which is pi. and the number of iterations. You'll find this example as well, so you can test it, and then we echo out the approximate value of pi. Now, this echo, we can actually put HTML in. So, for example, if I do H3, like so, and I close an H3. In fact, let's do H2. I'll change this one to H2. And I'll also just put it in some center tags, just to sort of show how these work together. And save it. And now we want to go ahead and do docker-compose. In my case, I'm going to check that it's not already running, and I'm going to remove the old ones. And I'm going to do docker-compose up-d. And now you'll see there's two containers. There's the PHP FPM, which is what's passed, does the PHP file processing, and the Nginx web server. And these will work in conjunction in order to run PHP. So now we're going to use this in tandem with our reverse proxy. So that was ng1. So I will simply go into here. This is all correct, sorry. Go into data and look at the nginx.conf. And the server now is going to be ng_php. This is the host name of the PHP Docker container that we just set up. And also I renamed the upstream block, to PHP Docker. So the upstream block is called PHP Docker. The server is called ngphp. So now we pass through to PHP Docker. So if you remember, the request comes in on 80, then passes it through to PHP Docker. PHP Docker then passes it through to the ngphp Docker container. So now we're going to make sure this is up, like so. And now if you go to cat.ultra, you'll see that the approximate value of pi is returned because we're calculating our PHP script. Or, sorry, our PHP script is calculating pi. So just to sort of show, if I go out of here, so out of the proxy now, and into ng_php, and I were to go into data and into the HTML folder, and we'll go into this PHP file. Let's do, let's create value 1 equals 12, and value 2 equals 12, and then result equals value 1 plus value 2. So we're just adding these numbers together here. And then under this, we'll add a line break in HTML here. So this will be non-centered. So we'll add a line break, and then we'll echo like so the result. And it says unexpected variable on line 26. And the reason for that is because I didn't put a semicolon here to close the line. Refresh that and you'll see this is 24. If we, I don't know, instead of plus we'll do times. And we'll actually add another value. Add quite a big number. So we'll do times and then plus value 3. And now, if we refresh this, we get this number. So that's how PHP can work with Nginx and can allow you to do more complicated things. If you want to expand this further, I suggest you go ahead and Google, for example, using PHP with MySQL or MariaDB. That would be a really good entry point here to learning how powerful it can be to use PHP instead of just plain HTML. Hi, welcome to lesson 6. We're going to be utilizing Nginx as a video streaming server. So I'm going to go ahead and hop over into the VPS and I'll sort of explain what this is and show you how we can set it up and use it. So the reason I want to show you this in this course is this is a non-standard use case of Nginx and it actually requires a separate module. Now you'll see here in the documentation for this module it supports all sorts of things. And you would normally basically build Nginx from source and add the RTMP module. Now, we won't be doing that because we'll be using Docker. However, the question you might have is, what is RTMP? Well, if you've ever watched, for example, a Twitch stream or some sort of stream online, the streamer will be streaming using software like XSplit or OBS to an RTMP server. Now, in the case of these websites, they'll then be distributed through some sort of CDN and not directly off the RTMP server. But for our use case today, we're going to use a direct RTMP server, So, instead of having to compile and build this module, we can use a Docker image that was already created. So the link for this will be below. This is basically just the RTMP pre-compiled and set up, and you can see it gives us some instructions. So if we go over to the VPS here, and I reconnect, you'll see I have created a server called NGVS for video server. And if we go in here, you'll see there's just a Docker Compose and no data file. This is because we don't store any data. There's no web page to load or anything like that. We are simply taking video in and streaming it out. So when we look at this Docker Compose, it's super simple. It's a version 3. It's called Nginx RTMP. We give it a container name. And we use this image here. And this image matches the image on this GitHub repository. You could see. So, once you've gone ahead and done this, you'll need to forward the ports. You cannot run this through our reverse proxy. It will not work because our reverse proxy is an HTTP proxy, not an RTMP proxy. So you'll want to open the port 1935, which is the default RTMP port, and then you'll want to run this. So I'm going to do stop in my case and RM just because it's running. But you will then do docker-compose. And if I hit return, if I hit return, this will now create and attach, and this will look a bit weird, right? Because you'll see nothing. And when I first did this, I thought, well, this isn't working properly. I've done something wrong. No, this is exactly the expected behavior. So we're going to use some software called Open Broadcaster. And now this allows you to do things like put text on your broadcast or videos. Now I'm using here a file called Big Buck Bunny, which is a royalty-free, as a non-copyright movie by the Blender Foundation. I'm just going to use this as a demonstration. You could obviously put game capture or display capture or whatever you need. So what we're going to go ahead and do is you're going to come across to settings and you're going to come across to stream and you're going to choose custom because we're not streaming to Twitch or YouTube or Twitter. We're streaming to our own server. You're going to put RTMP : and the IP address of your machine, your public IP address, /live. The /live is important. And in stream key, you're going to put something random. In my case, I put meow. So now we can go ahead and click OK. And we can go ahead and click Start Streaming. And you will see that this goes live with a green circle. And we can obviously stop streaming too. And when you stop streaming, you'll see here that this was published in the past, this meow key stream. So I'm going to go ahead and start this. And now we need to connect to this with a video player. So I'm streaming this out to my VPS, and then from my local network, I'm going to pull it off the internet. So you're going to install something called VLC. You can just download this off the internet. And then you're going to go to Media and Open Network Stream. Now you're going to put RTMP, the IP address, /live, / your stream key. So mine is meow. So just to show this again, in settings, stream, custom, /live, and then it would be / whatever this stream key is, meow. So now if I go ahead and click play, this will take a second to connect. But there we go. This is now playing. And what we can go ahead and do is start some video. By unhiding this source. You'll see there's a delay because it's streaming through the internet. Or I might have to restart it actually. So I'm going to stop. I'm just going to restart this quickly. Open network stream, play. just going to quickly restart my VLC. Sometimes VLC bugs, that's all. You'll see there's nothing wrong with the setup because this will play. There we go. I could edit that out, but I wanted to show that there was no problem with the server. So now our video is playing. And obviously if we put this side by side, you will see that if I, for example, add text here, there'll be a delay because this is going up to the VPS and back down. But then hello will appear, like so. And I can adjust, for example, the media source volume, and that will do the same. Now, it's important that with the way this is set up, if I stream, for example, at 3600 kilobits in H.264, that's exactly what will come out of the server. You can, with a custom config, set it to use FFmpeg, which is a video encoder, to then change what's ingested. So I could send, for example, 30,000 kilobits to the Nginx box, and then it could crush it down using FFmpeg. And you could have different streams at different qualities. However, that isn't going to be covered in the scope of this this series. Now, if we go to Tools and Codec Information, you'll see it's just a MP4A, and it's basically MPEG-4 H.264, 1920 by 1080, frame rate of 30. If I stop streaming this, I go to Settings, Video, and I change this to 720, and I change this to 720. And let's change this to 25 and resize this, fit to screen, and now I start streaming again. Like so. We'll then go ahead and restart VLC. Okay, so here we are with VLC restarted, and now we can go ahead, and if we go to codec information, you'll see this is now 1280 by 720. So whatever you set in OBS will be forwarded directly straight through. There is no transcoding. So hopefully this has sort of showed you a cool use case for Nginx, and one outside of the normal scope within HTTP, and really demonstrates to you how powerful the software can be and how it can be enhanced with modules. Okay, so now we have Docker Compose. Let's just sort of check our whole setup works. So we're going to go ahead and we're going to go nano, and any file with Docker Compose you'll want to call docker-compose.yml. Now we're going to create a folder for each application. So in this case, we're actually going to use Apache, which is a different web server, but just to show that our Docker and Compose is working, so we're going to make a directory called Apache_1. We're going to cd into Apache 1. And we're going to create a docker-compose.yml file, and I'm going to paste one in that I've already created here, but you can see you have the version. This is the version of Docker Compose. You have services. You can have multiple, but in this case we've got one. It's named Apache. The Docker image we're using, these can be pre-made. In this case this is a pre-made one for Apache 2. The container name, in this case I'm just going to change this to example_app_demo, and then you have this port mapping. So this is basically, this is internal to the container, so the container will broadcast on 80, and then externally to the rest of the world it will be on port 8080. And then here you can see that this is /website, so the current directory /website will map to internally to the container of user local Apache htdocs. Now this is where Apache stores its web pages. So what you're going to want to go ahead and do is, you can change this if you want. So in my case I'm just going to call this data, and this will automatically create data. So if we do Control X in nano and Y and save, and if I clear this and do ls, you'll see docker-compose. If I type docker-compose and I type up, you will see it will pull the image. And now it will go ahead and run the server. Now I'm going to do Control-C to exit this a sec, and I'm going to use cat to just quickly look at that Docker Compose, and you can see that our external port here is actually 8080. So if I go ahead and run this again, so now as you can see we're on 8080, and you can see here in the background that when I refresh, my server's working, or my Docker application. So if I do Control-C here, it's going to stop the app, and what I'm going to do is I'm just going to put a file in the data folder, so cd data, and I'm going to go ahead, I'm going to use nano, and I'm going to create a index.html, and I'm just very quickly going to create some very bad HTML. This is not in the scope of this video. This is an out-of-date tag, as anyone who does HTML will know, but we'll do for now. Okay, so now we have this file, as you can see. What we're going to do, I'm just cding back a sec, so cd ... goes back. And we're going to do docker-compose. Now before we did up. Now this brings it up, but if I were to close this SSH session, the application would not work. So what we can do is -d, and this will detach it. So now it's running in the background. Now you might say, well, how do I then stop it? Well, you do docker-compose. You have to be in the same file as your docker-compose file. You can do docker-compose stop. This will stop the app. Or you can do, if we do docker-compose up-d again, and let's say we want to see what's happening on the screen, you can do docker-compose logs -f for follow. And now, if we refresh this, you'll see hello user. So that's the end of lesson 2. You have Docker set up, you have Docker Compose set up, you know how Docker Compose works, and we've created a very basic Apache web server. Now obviously Apache is not the web server we're going to be using in this series, but I just used it to create a basic demonstration of how we can go ahead and use Docker.